Now let's look into what are the types of languages and the difference between them and figure out when to use which programming language based on the scenarios. So to begin with, we have something called assembly language. And what happens is you write code in assembly language, and then there is a software which is called assembler, and that assembler converts this assembly language into a binary language. This is extremely fast. Till today, whenever you want to develop something which has to run extremely fast, the code is written in assembly language. It is used in some of the missions, outer space missions. It is also used in some of the network related software. It is also used in applications like Excel, where you have to do an extremely fast computations. So if you need a very high performance software, it has to be written in assembly language. However, no more applications are being developed here because it costs a lot of time and a lot of manpower. So it has been restricted to those areas where there is a requirement for high performance. Then you have something called high level languages. The earlier high level languages which became very popular is C and C++. In these languages, what happens is you have a software which is called compiler, and that converts your high level looking language into binary. And this process is called compilation. Examples, you can use this kind of software. The programming for C and C++ is done in some of the applications like, say, self-driving cars, where you need it to execute faster. It is also used in your networking solutions where it helps in transferring data. Imagine using a slower programming language and you are driving a car or you are changing a lane, and if that program takes little longer to execute, it may cause a major accident. So in time critical applications where the risks are very high, you choose those languages which execute really fast. These languages like C and C++, they are easy to write code compared to assembly, but they are not that easy. They still have lot of restrictions on writing semicolons, for following a certain syntax, and they have lot many syntaxes which makes it hard for people to learn. Then you have more advanced high level languages like Python and JavaScript, and also Java and C#. Now these languages behave differently for a different purposes. For example, C and C++, you have to do compilation and generate a binary file. Now this binary file is generated for a particular CPU architecture, be it x86 or ARM, and also for a particular operating system. For example, if I have built an Android application which is based on Linux, I cannot take it and run it on Windows. Most of the phones are using ARM architecture for the CPU and operating system is Linux. I cannot take that application and directly run it on Windows. And similarly, a Windows application cannot be run on Android, or a Windows application cannot be directly run on Mac. That is because these languages are compiled and the binary file that is generated is platform specific. The advantage here is it gives you immense, very good performance, and the trade-off here is between having a good performance versus generating that application for a specific purpose. Now there are libraries that are written in C and C++, but then it gets compiled separately for Linux, for Mac, for Windows, for Android, and those libraries are generated for different CPU architecture and operating system, and that can be done, but it will be an one-time task to generate that and then ship those softwares to these devices. Hence, this is more time consuming and also costly. This is where the trade-off is done for the performance versus cost. Now coming to Python and JavaScript, these languages, when they have something called interpreter, which finally converts that language to binary code on the target machine or the computer. So in both JavaScript and Python, the code is delivered to the client, be it your phone, be it your PC or Mac, and on that machine, based on that operating system and based on the CPU architecture of that machine, the interpreter finally converts it to the binary code and runs it on that machine. and they have some optimization which is they call as just-in-time compilation to increase the speed. However, in this case, these languages are definitely slower than assembly and C++. Hence, Python and JavaScript are mainly used in those scenarios where they are not time critical. For example, Python is getting used widely in data analysis, artificial intelligence, where you submit a job, you submit a request to process some amount of data, and you are okay to wait for some time for the processing to finish and you get back results. However, here the trade-off is on ease of coding. Python language has way more less restrictions and syntax restrictions, and it is so easy for any beginner to pick up. That is the reason in many of the universities and colleges, Python is being taught as a first language, followed by JavaScript. Now, in all your web applications and even some of the backend, the JavaScript is used. As I mentioned, even for JavaScript also, on the target machine, there will be an interpreter which will run it. What it means is, to run the program or a software written in Python or Java, you have to install this interpreter on that machine. And that interpreter software is different. Say a Python interpreter for Windows is different, Python interpreter for Mac is different, Python interpreter for Linux is different. So it will vary based on where you are running. Now finally, the Java and C#. So these are two languages where it is neither this extreme end where it is a binary, nor it is an extreme end where it is still high level language. It is somewhere in between. What it means is, for these two languages, we have a compiler that generates an intermediate code which is also called bytecode. And this bytecode is delivered to the devices on which it has to be run. And on that device, it is finally compiled into a binary code at the runtime. Again, this also has JIT, which is just-in-time compiler, to accelerate the performance of the applications. For even C# and Java, you also need an environment to be set up on machines. In Java, it is called JVM, which is Java Virtual Machine, and in case of C#, it's called .NET. This need to be installed because only these know how to convert this intermediate code into the binary code. And without doing that, this application or the library cannot be run on this particular machine. Now, a very big question, right? If you are entering engineering or you are studying computer science, which language to learn? And here is my suggestion. To begin with, you start learning C or Python. You have to learn one language really well. If you learn one language really well, then it is very easy to learn the other languages. Look into your college curriculum and see whether you have C or Python, but make sure that you learn that language really well. And after that, you can learn one of these languages, either Java or C#. So why I suggest C is because in case when you learn C, you get lot of system concepts very cleared. The way it manages memory, the way the context is managed, the way some of the things are done in terms of passing the information to a function and retrieving back, all these concepts get very cleared if you are writing code in C. That is why I advise you to learn C from this bucket, and then learn Python from the scripting bucket, and then learn Java or C# from the high level languages from the backend side. So, and to begin with, pick just one language, either C or Python, and learn it completely and thoroughly, and then you learn the other two languages. By doing so, you will skill yourself in such a way that you will never have to worry whenever there is a new language, whenever there is a recession, whenever the industry is going through any shifts. To be honest, in the years to come, there are going to be lot more languages that will come. But if you build a solid foundation in this, you never have to worry about a job, or you never have to worry about those new languages that will come. You will always be able to learn, ramp up quickly, and continue to work and build wonderful things. I hope this clarifies.